All right, guys, welcome to our first video. Really just a quick review on things that you've already seen. It's not going to look that much different than what you did in 8th grade and 9th grade. We might add a few extra terms into the problems, but it's rules and things that you've already seen. So I'm going to go kind of fast. For those of you that didn't pick it up in class, you're welcome to watch the parts that you need to watch. For those of you that were absent, I recommend you hang out through the whole video. So we're talking about multiplying powers with the same base. So just a couple of rules to remind you of. And the first one is an equation such as 3 to the 4th times 3 squared is equal to 3 to the 6th power. We can combine these together when they have the same base. When both of these have a 3 in front of them, we can combine those together into 3 to the 6th. So just remember that rule, what it looks like is if I have a to the m power multiplied by a to the n power, that equals the base stays the same and we add together the exponent. So right here, the 3 stayed the same, but we added the 4 and the 2. Again, that works because both of these have a base of a. If I had something like 3 to the 4th power times 2 squared, I can't add these exponents together because 3 and 2 are a different base. Or if I had a squared and b squared, again, I can't add these exponents together because a and b are not the same thing. They're different. And here's it bothers me for you to not know why it works. So here's why it works in this example. 8 to the 3rd power times 8 to the 6th. Remember, 8 to the 3rd power, or 8 cubed, is just 8 times 8 times 8. And then I'm just multiplying 8 to the 6th power, which is 6 more 8s. So 1, 2, 3, 4, 5, 6. So really, when I'm multiplying all of this together, I'm actually just multiplying 9 8s together. So that is equal to 8 to the 9th power. So if the bases are the same, add the exponents. And it doesn't matter if they're positive or negative. So in this example, 0.5 raised to the negative 3 power multiplied by 0.5 raised to the negative 8. I'm going to do the exact same thing. My bases are the same, 0.5, but I'm raising them to negative 3 plus negative 8, which is negative 11. So it'll be 0.5 raised to the negative 11th power. All right. Be careful when variable factors have more than one base. Make sure you only combine those powers with the same base. So that goes back to this example here. We can't combine these together because a and b aren't the same thing. All right, so let's do a couple. 5x to the 4th times x to the 9th times 3x. Remember this, there's a little multiplication right here and a little multiplication right here that you don't see. We know it's there. So really, we're just multiplying all this together. And because everything's being multiplied, I can take the 5 and the 3, and I can just multiply those together first. And then I'm left with x to the 4th, x to the 9th, and x, which is really just x to the 1 power. So how many x's is that? That's 4 plus 9 is 13, plus 1 more x. So I'm multiplying x to the 14th power. So that's just going to be 15x to the 14th power. Same thing here. I've got negative 4c cubed times 7d squared times 2c to the negative 2 power. Be careful. The c's and the d's can't go together. So we have to be careful that we only combine the things that are the same. But I've got a negative 4, a 7, and a 2. I can multiply those. So negative 4 times 7, that's negative 28. Negative 28 times 2 is negative 56. I know I'm going kind of fast, but this should all be review for you. And then c cubed, I've got 3 c's right here, and I've got negative 2 c's. So if I take 3 plus a negative 2, that just leaves me with c to the 1st power, because 3 plus negative 2 is 1, and then I have d squared left over. So that's going to be negative 56. C to the 1st power, we can just write it as c, and then d squared. All right, next rule. Multiplying with scientific notation, you're not going to see this a lot, but it does like to come up on the ACT. It does like to pop up on problems every once in a while. So we just want to remind you what scientific notation looks like. Remember, scientific notation is going to have some number multiplied by 10 to some power up here. This number in front can only have one number in front of the decimal place. So if you look at our example, it says 1 cubic meter of water has a mass of about 9.98 times 10 to the 5th grams. So the 9.98, this is scientific notation. There's only one number in front of the decimal, and it's being multiplied by 10 to the 5th. And if you remember, what that means is I'm taking 9.98 and when I multiply by 10 to the 5th, I move the decimal 1, 2, 3, 4, 5 places, which means that this is actually 998,000 grams. We just write it in scientific notation. So each of these grams of water contains about 3.34 times 10 to the 22nd molecules of water. So we have the number of grams. Each of those grams has this many molecules of water, again in scientific notation. And it wants to know how many molecules of water are in a swimming pool that holds 200 cubic meters of water. So what it's asking us to do is we're going to take each of those 200 cubic meters, and we have to multiply that by this number, 9.98 times 10 to the 5th. And then each of those has this many molecules of water. So I'm going to multiply by 3.34 times 10 to the 22nd. So I've got tens right here that can combine. That's 10 to the 27th power. And then I have 200, I have 9.98 and 3.34. So when I multiply that, I take 200 multiplied by 3.34 multiplied by 9.98. When I hit enter, I get 6666.64. So 6666.64 times 10 to the 27th. It wants our answer in scientific notation, so I'm not done. Remember, this decimal is supposed to be right here, which means I have to move it 1, 2, 3 places to the left. So it becomes 6.66664 multiplied by 10. If I moved it 3 to the left, that means I have 3 more 10s right here. So that becomes 10 to the 30th power. And that's scientific notation. Again, it's not going to come up very often, but just in case, I want you to have a quick reminder there. Okay, next rule, raising a power to a power. This is one that people mix up with the first one we talked about. What if I have a to the m power raised to the n? That's kind of confusing. So look at this example right here. 5 to the 4th is in parentheses, and we're going to raise that to another exponent. So we have 5 raised to the 4th. All of that is being raised to the 2nd power. And really, guys, all that means is I have 5 to the 4th multiplied by 5 to the 4th, which, going back to our old rule, you add those together, and that's just 5 to the 8th power. But the shortcut is when you're raising an exponent to another exponent, you're going to multiply the exponents together. So 4 times 2 gives you the 8. Right there. So it doesn't matter what is in front. If I'm raising it to an exponent and then raising it again, I multiply those exponents. So in this example here, a to the 3/2 raised to the 3rd, really that just means a to the 3/2 times a to the 3/2 times a to the 3/2. We don't want to add those together because I know the shortcut. A to the 3/2 raised to the 3rd, I'm just going to multiply 3/2 times 3, which is 9/2. So all that is a to the 9/2 power. A similar rule we just need to be careful of is, what if there's more than one thing? What if it's not just a 5 on the inside? What if there's an A and a B being raised to an exponent? So what if I have 3 times x all being raised to the 4th? And the shortcut is kind of I guess it's kind of like distribution. I'm taking 3x to the 4th, which is just 3x times 3x times 3x times 3x, which you can multiply all that together, 3 times 3 times 3 times 3, and x times x times x times x. The shortcut is this 4 goes to the 3, and it goes to the x. So you can just use the shortcut that it's actually just 3 to the 4th times x to the 4th, because I have 4 3's. So that's my 3 to the 4th, and then I have 4 x's. So I get x to the 4th. 3 to the 4th, we know what that is. That's 81. So this is just 81x to the 4th. And if you don't remember how to do that on your calculator, 3, use the little caret button to raise it to the 4th power, hit enter, and it becomes 81. So 81x to the 4th would be your answer there. 4b, all raised to the 3/2. This one's a little bit harder to write out this way, so let's just use our shortcut. Let's do 4 raised to the 3/2 and b raised to the 3/2. So 4, we distribute that exponent, and b to the 3/2. Now this works because we're multiplying. If this said 4 plus b raised to the 3/2, we could not do this rule. It only works because everything's being multiplied. That plus sign on the inside messes us up. So don't use this rule there. We'll do that in a couple of weeks. We can only use this rule when everything's being multiplied. So we have 4 to the 3/2 and b to the 3/2. Again, on your calculator, we can do 4 raised to the 3/2. So I'm going to put 3/2 all needs to be up there in that exponent. So I'm going to put it in parentheses, and it becomes 8. So 4 to the 3/2 is 8. B to the 3/2 is still just 3/2. So that would be your final answer right there. So that's raising a power to a power and distributing that exponent. Okay. Again, I know I'm going fast. You've done this. You've seen it. It's nothing new. So we're going to breeze through it pretty quick. If you need to go back and watch things again, you're more than welcome to. The last thing today, this bottom stuff, we're going to go over another day. But today we're talking about, last thing is raising a quotient to a power. So what if on the inside, instead of having AB raised to the n, 2 things being multiplied, what if I have 2 things being divided? Well, you do the same thing. That exponent is going to go to the a on top, and it's going to go to the b on the bottom, and it becomes a to the n times b to the n. So this 3 goes to the top, and it also goes to the bottom. So this becomes 3 cubed on top, and on the bottom becomes 5 cubed. So that 3 goes to the top numbers and the bottom numbers. In my calculator, I can plug that in. I know what I can do. Whoops. I can do 3 raised to the 3rd power. That's just 27. And 5 raised to the 3rd power is 125. So that becomes 27 over 125 would be your final answer for that one. X over 9, all raised to the 5th power. Again, that 5 goes to the top. The 5 goes to the bottom. So that becomes x to the 5th power divided by y to the 5th power. And we can't simplify anymore because we don't know what x and y is. That would be your final answer. Okay. So that's day 1. That's homework 1. That's all you're going to see on there. So if you go on to Math Excel, homework 1 should be open. Remember that it is going to be due next class period. So that's due next class. Even if you were gone today, it's still due for you. So make sure you get that done at home. You have a couple avenues to get help. Come and see me before or after school. You also have a Get Help button that you learned about in the orientation right there on Math Excel. If you're struggling with a problem, you don't know how to do it, go ahead, hit that button, and it'll give you some clues. It'll give you some options to kind of help you out. All right, good luck.